Okay, so today we're going to do something pretty wild. We're going to bring one of art history's greatest lost treasures back from the dead. I'm talking about a masterpiece that vanished centuries ago. And the way we're going to do it? By treating it not just as a piece of art, but as a piece of data. Let's dive into how this incredible fusion of art and tech actually works.
You know, for centuries, Leonardo da Vinci's massive mural, The Battle of Anghiari, has been this legendary thing. People called it a masterwork of motion and pure fury. But then, it just disappeared. The story goes it's actually hidden behind another fresco on a wall in Florence. The problem is, we can't see it. All we have left is, well, this, a copy.
So, this drawing you're looking at, it's a chalk and ink copy made by another master, Paul Rubens, and it's literally our only window into what Leonardo created. You can just feel the raw energy, right? The twisting bodies of men and horses all locked in this brutal, chaotic fight over a battle flag.
And it is so powerful. But here's the thing. It's just a single, frozen moment in time. It's kind of like looking at a photograph of a hurricane. Yeah, you see the power, you see the shape of it, but you can't feel the wind. You can't see the swirling chaos that Leonardo was an absolute genius at capturing.
So that got some people thinking, what if we could take this snapshot and just hit play? What if we could actually unfreeze this 400-year-old scene and watch the battle unfold in front of our eyes? Well, buckle up, because that's exactly what we're going to do.
And the key to all of this is something called a computational simulator. Now, this thing looks at Rubin's drawing, but it doesn't see a static image. Nope, it sees a set of instructions for a dynamic system. It sees every single figure not as just a line of chalk or a bit of ink, but as an active participant in a real battle.
So how does that even work, right? Well, the tech behind it is called agent-based modeling. And honestly, the easiest way to think about it is like a video game. Each warrior, each horse in that drawing becomes its own little character, or agent. They're all independent, and we just give them a really simple set of rules to follow, like seek out the enemy, stick close to your allies, and, try not to run into each other.
Okay, so where do we get these rules? Are we just making them up? Not at all. They're actually pulled directly from the artwork itself. By analyzing the composition, we can figure out who's who and what they're doing. So let's meet the players in this digital drama.
All right, first up, we've got the Florentine combatants. The simulation picks out 12 distinct agents fighting for Florence, all based on the figures we can see in Rubens's drawing.
And on the other side, 10 Milanese combatants. So right away you notice there's a slight imbalance in the numbers, which, could definitely change how this whole thing plays out.
And then, right in the middle of all that chaos, are the horses. 7 of them, rearing and charging. And these are not just background decorations, they are seriously powerful agents that are going to have a huge impact on the flow of this fight.
Okay, so this is where it gets really fun, because now we get to play director. See, the agent's actions are all controlled by a few key parameters. We can set the speed of a cavalry charge, for example, or we can dial up a soldier's aggression level, or maybe we want to make them stick together more as a unit. By just tweaking these numbers, we can create completely different versions of the battle, all starting from that same single image.
And that is where the real magic happens. We can start running different scenarios, all these what-ifs, to really explore the dynamics Leonardo was trying to capture. Like, what happens if one side is way more aggressive? Or what if the soldiers just fight for themselves instead of as a team? Let's take a look.
Okay, check this out. We're looking at 2 totally different outcomes here. On the left, that's what we'll call our balanced melee. You see that bright hotspot right in the middle? That's the heart of the battle, a really tight clash, just like in the drawing. But now look at the right. All we did here was turn down the cohesion. Basically, we made the soldiers fight more for themselves. And boom, look how the whole fight just scatters into these little duels all over the place. A single tiny change to the rules, and the entire battle is transformed. All right, so that's the where of the battle, but what about the who? What happens to the actual soldiers if we start changing the story of the fight? So what you're seeing here, these graphs are basically charting the human cost of the fight over time. Look at the one on the left. In a balanced fight, you can see the blue Florentine line and the red Milanese line. They're dropping at about the same rate. It's just a grim war of attrition. But now, look at the graph on the right. In this scenario, we made the Florentines more dominant, and just watch that red Milanese line plummet. We are literally watching a Florentine victory unfold right there in the data. And this graph puts 5 different alternate realities of the battle, all on one chart. Each of those colored lines is a different what-if scenario, tracking how many warriors have fallen over time. Check out that purple line. That's a battle climax scenario, where the casualties just skyrocket.
Now compare that to the orange dotted line. That's a cavalry charge, and it's a much, much slower burn. It's amazing. We're looking at 5 different stories of the same battle, each one with its own unique rhythm of life and death.
So look, this is all incredibly cool, but you might be asking, so what? Why does this even matter? Why go to all this trouble to turn a Renaissance masterpiece into a computer simulation? Well, it's about something much bigger than just this one lost painting.
What this project really does is build a bridge between two worlds that almost never talk to each other. The world of art history, which is all about interpretation, and the world of data science, which is all about numbers and analysis. It's like we're creating a whole new language to talk about and understand art. And the potential applications here are just huge. Researchers can now analyze composition with actual numbers. Students can get a real gut-level feel for how complex systems work. Military historians can use this to explore Renaissance battle tactics. But just imagine this. You're in a museum, and you could actually interact with the painting and see the artist's choices about movement and energy play out right in front of you. How cool would that be?
I think the project's own documentation says it best. This tech, it makes the invisible dynamics behind a static image visible, interactive, and scientifically reproducible. It takes all that energy, all that tension that an artist pours into their work, and it makes it something you can see, something you can play with. It just lets you experience the art in a completely new way.
And that really leaves us with a pretty fascinating thought to end on. We've used this technology to find the ghost in the machine of a lost Leonardo masterpiece. But what about all the masterpieces that aren't lost? What other dynamic stories, what hidden rules are just waiting to be discovered inside those static frames hanging in museums all over the world? Just think about what else we might see when we learn to look at art, not just with our eyes, but with data.